This video gonna prove some facts about modular arithmetic. The first one says if A is congruent to B mod n and m divides n, you can replace n with m. You can replace n with m. The next one says if A is congruent to B mod n and C is any positive number, then A times C is congruent to B times C mod n times C. Everything got multiplied by C. And the next one says that if A is congruent to B mod n and A, B, and what you're dividing by, n, are all divisible by d, you can divide the a by the d, the b by the d, as well as the n by the d. Get smaller numbers that way. Okay, so how about we get right into the proof? But before that, consider subscribing to my channel. That way you get to see all these wonderful proofs that I do all the time. Okay, so the first one, they tell us that A is congruent to B mod n. Well, that implies that A minus B is some multiple of n, and m divides n means that n is some multiple of m. So I can, those symbols tell me I can replace n with nm, or n. So these two together imply that A minus B is Q times Rm, which is QR times m. That's a multiple of m. This minus that is a multiple of m. That means A minus B is A is congruent to B mod m. Mod m. Just real quick to tell you, so if you had mod 8 and you had, I don't know, 12 and 20. Is this, so what you can do is to make the numbers smaller, that's 2 cubed. You could, 2 divides into 8. So you can replace it with 2. And then yeah, the 20 minus 12 happens to be 8, which is 2 times an integer. So you can make that number smaller. Okay, number 2, you can multiply everything by C. Okay, so A is congruent to B mod n. That implies that A minus B is a multiple of n. Well, that implies C times the left side is C times the right side. But that's CA minus CB, and rearranging this a little bit, that's Q times CN. This minus that is an integer multiple of this. That means CA is congruent to CB mod CN. Not sure when you would want to do that, but you're allowed to. Okay, next one's interesting. You have that, number 3. You have A is congruent to B mod n. That means A minus B is a multiple of n. And they tell you that you can divide a by d. A is divisible by d, that is a over d is an integer, b over d is an integer, and q over d is an integer. Let me just write that as one integer minus b over d. We're dividing by d, excuse me. Divide both sides by d. A over d minus b over d is equal to q times n over d. But they're telling us d divides a. That is, this is an integer. D divides b. That's an integer. They told us d divides n. That's an integer. So, now we have one integer minus another integer is q times an integer. That means a is congruent to b mod c. This tells us that a over d minus b over d, a over d is congruent to b over d mod n over d. You can always do that as long as these are all integers. The math allowed you to. I took a minus b equals qn, because a is congruent to b mod n, and I divided each and every term by d. And that's clearly allowed, so I got this equation. And the fact that everything in the brackets, in each bracket, is an integer, we got it. That completes this video. Proves a few facts about modular numbers. Subscribe to my channel if you like watching videos like this where we prove things, which means we understand it in the end. See you guys in the next video after you subscribe. Watch and learn.